Start, sir.
Hello, I made the teaching aid that is the for 9 student teaching coordinate geometry relation. Now we know that that horizontal line that is known as the x-axis and the vertical line that is called the y-axis, and where both the lines will intersect that is called the origin. Now we can explain the students what is the first quadrant value and the second quadrant. In the first quadrant, x coordinate and y coordinate both are the positive. So we can ask the students to put the pointer that is the 7 and 6. So they will show the pointer that is the 7 and 6. This is the first quadrant value where both the points are positive. Both the coordinate value are positive. Now in second quadrant, we ask the students what is the x coordinate value and y coordinate. So x coordinate is the negative, y coordinate is the positive. So that will show the students that is the 7 and minus 7 and the plus 8. So that is the second coordinate value. Now in the third quadrant we ask the students what is the x coordinate value and y coordinate value. So they will give the answer that is the value will be x will be negative and y will be negative. For example, minus 8 and minus 7. That is the third quadrant value. Now in fourth quadrant value, we will ask the students what is the x coordinate and the y coordinate. So x coordinate is the plus positive and y coordinate is the negative. For example, we taken 0.8 and minus 7. So this is the points are there. Now we will explain the equation of the line that is the, for example, y equal to minus 7. So that line intersect the x-axis below the origin at the 7. So we so that this point is the y equal to 7, that is the equation of the line at the 7 unit below the origin. In same way we can explain the equation of the line on the x-axis, that is the x equal to minus 8 on the left of the 0 origin, that is the x equal to minus 8. So this is the equation of the line. Also we can explain the that is the collinear points we can show, like here that is 7 and the 0. This point will be lies on the x-axis. This will be lies on the axis, that is the 7 and 0. So that will be the 7 0 and 7 and 8. They are on the same line, so that points are called the collinear points. So this we can explain. Now also by using this teaching aid we can explain the rotation of the axis. This initial arm on the x-axis. So on the x-axis we call the initial arm, and when you rotate it is called the terminal arm. Now it is on the x-axis, so it is the initial arm. Now we will rotate in upward direction, that is the anti-clockwise. If you will rotate in upward anti-clockwise, then angles will be measured in positive way. If you rotate in the downward direction, then angles will be measured in the negative way. For example, if you rotate in downward direction, that is the clockwise, that will be the clockwise, that will be the angle will measure in negative. Now for example, suppose I rotate the initial arm in the anti-clockwise and the terminal arm will be lies in the second quadrant. So it will be lies in the second quadrant. This is the second quadrant. So measure of the angle will be between 90 and 180. If I'll rotate this initial arm in the clockwise, that is the downward direction, in the second quadrant, that is the second quadrant. Now measure of the angle will be between minus 180 and minus 270. If the initial arm rotate and it will be and the terminal up to the axis, y-axis negative, then what will be the measure of the angle? So this will be the y-axis negative. So then the measure of the angle will be minus 90 and plus 270. If you take the anti-clockwise, that is the anti-clockwise, that is the downward direction, upward direction. If you come, then it will become 270 positive, and if you go in downward direction clockwise, then it will become minus 90. And if there will be no reflection means if the initial arm is on the x-axis only, then there will be no reflection or deflection, we can say. There will be no any angle, so that is they call the zero angle. There is no deflection. So this is the for teaching the 9th standard geometry. For watching, thank you.